Hi everybody, this video today is going to talk about lesson 10.7, which is Cpctc, and my title fell off my page. So this is in your booklet on page 57. So Cpctc stands for corresponding parts of congruent triangles are congruent. And so here's what it means. If two triangles are congruent, then the corresponding angles and corresponding sides are also congruent. So if we look at the diagrams, we're going to talk through this, what this even means. I have written out here a congruence statement that we have triangle ABC congruent to triangle DEF. So here's ABC, here's DEF. I'm saying that they are congruent. Well, if they are congruent, then angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. And we find that by putting the letters in order, but also by looking at the triangles and seeing what pieces go together that way. So we could say angle A is congruent to D, and so forth. We can also talk about the sides. And so we know if these triangles are congruent, then we should also be able to say that this side is congruent to this one, and this side is congruent to this one, and this side is congruent to this one. And so we can say that as statements also. We can say that segment or side AC is congruent to side DF, and so forth. And that again, that comes from the letters in order. It also comes from the examples. And so when you have this in a proof, as far as the reason goes, the reason is you say Cpctc. So in our proofs, we'll be going through some proofs, and we'll prove that triangles are congruent. And after we've proved that triangles are congruent, then we'll say Cpctc. All right, let's take a look at some more examples. All right, so here's our first proof. I have the given information filled out, so take a second to fill that in. In addition, these are not marked, so I'm going to take some time to mark these. So I've marked the information that I know, and now as I look at it, I can tell that there's this shared side, this BD, which is shared by both of them, so I can say that side BD is congruent to side BD. And I notice that I need to put my bars over my letters. So I'm going to put those bars up there, those lines up there. Now, what is that reason? Do you remember? We always call that reflexive, because when something is equal to itself, it's reflexive. It's like if you look in the mirror, that's your reflection. It's yourself. So if you're equal to yourself, that's the reflection. Now, from what we've done so far in the past couple of days, we should know that we have three sides filled out here. So that should mean that we should be able to say that the triangles are congruent. And I want to make sure I go in order. And I like to go, I've said this before, the first and then the second, then the third. It doesn't have to be, but it just kind of helps me keep it in order. So I'm going to say BAD. Triangle BAD is congruent to triangle. Okay, if that was BAD, then this one's going to be DCB. And the reason for that, I have all three sides. So that's side, side, side. Okay, then what Cpctc allows us to do is it allows us to say, okay, if those are congruent and those triangles are congruent, then we can say all the angles are congruent also. Even though we didn't mark any angles, if the triangles are congruent, then also all the angles, but this part of it just says these angles, are congruent. So my reason there is Cpctc. So we're just going to do the same thing that we've been doing the past couple of days, prove the triangles are congruent. Once we get them congruent, we will do Cpctc. Okay, let's take a look at another one. Again, I have already filled in my information. The first one is given, obviously, so let me mark that. I like to have it marked so I can see what's going on. MA and TA. Then they say that A is the midpoint of SR. So here's A, here's SR. That means that these two pieces are also congruent. So we can say that SA is congruent to AR, and the reason is that's a definition of a midpoint. Talked about midpoint up here, so it just logically follows we need to talk about midpoint on the next step. Okay, so far we have two sides. Is there anything else we can get? We need to get at least one more. Looks like we can get this angle in the middle. So this angle which is angle A, but I need to use all three letters, so maybe MAS is congruent to angle TAR. What kind of angles are those? Those are vertical angles. And so vertical angles are congruent. And finally, now do we have a triangle? Yes, we do. We have a side here, we have a side here, we have an angle here, but they don't go in that order. They go in the order that it shows up on the triangle. And on the triangle, it is in the side angle side order. Okay, so that means that triangle, and again, I'll go in order, MAS is congruent to triangle MASTAR. On these, I noticed some people on the homework, on the assignment, getting the angle and the triangle symbols confused because you just weren't reading it very carefully. So just make sure you read those carefully and pay attention to what the difference is. Okay, so we have side angle side. Now it's saying, well, if all of that is true, then look what it's asking for. It's asking for MS and TR. That's this side and this side. Well, how can we say that? That's not even mentioned. But it is because of Cpctc. Since the triangles are congruent, all of the parts are congruent. All right, on the next page, you know what? Let's save this one for class. So we're going to move on and do this one together. So let's move on to the bottom one. Okay, here's why I wanted to do this, is that these deal with these parallel lines. So line MS is parallel to line TR. Okay, that's a given. That doesn't say anything about the congruence. It doesn't say they're congruent to each other. Now this next one, it does say they're congruent. So now we know they're congruent, but that little arrow means that they're parallel lines. All right, so we have that. We want to get to that A is the midpoint, all right? Well, when we have parallel lines, we need to start looking at things like alternate interior, alternate exterior. So let's go ahead and take a look at what we can do with that. It does not really matter which line we choose, MT or RS. I'm just going to choose MT. I had to choose one of them, so that's what I chose. And now I see that I have a transversal and I have these two angles which are congruent. So now I can say that angle M is congruent to angle T. Why are those congruent to each other? Because they are alternate interior angles. Okay, so we have alternate interior angles here. We have this side that is congruent. Do you see anything else we can get? Yes, this is an easy one. We should be able to locate it really easily. That is angle A is congruent to angle A. Of course, we can't say A because we have to talk about the actual angle. So I'll say angle MAS is congruent to angle RAT. Why do we know that? Because those are vertical angles. All right, so what do we have so far? We have an angle, we have a side, and we have another angle. And on the diagram, they're not in that order. They're not in the angle of ASA on the diagram. So I know they're in this order here, but when we talk about it, we need to look at the diagram. All right, on our diagram, we have a side here, we have an angle here, and we have an angle here. Or on this side, we have an angle here, and an angle here, and a side here. Okay, that is angle, angle, side. There's two angles and then a side. And so we need to say which triangles are congruent. So let's just, I'm going to start with S and go SA. No, that's M, isn't it? SMA. So when I did SMA, I went like along this parallel line and then over to the vertex. So I'm going to go along the parallel line over to the vertex, RTA. So those triangles are congruent because of angle, side, angle. Okay, now somehow usually what we do is we jump to Cpctc. So I think we're going to say Cpctc here. Look at what we're trying to get to. We have to kind of look and see, take our eyes off right in front of us and kind of take a big picture here. So we need to look at the big picture and say, okay, we're trying to get to A being the midpoint of MT. I'm going to erase some of this because it's starting to get messy. because I want us to be able to focus on what we need to focus on now. Now what we need to focus on is that A is the midpoint of MT. So here's A, here is MT, okay? If that's the midpoint, we must have to get to these pieces, this piece and this piece, okay? So can we say that? Can we say that segment MA is congruent to segment AT? Let's think about it. Does it fit with Cpctc? MA and TA, well, I called it AT, but TA and AT are the same thing. So yes, we can say that MA is congruent to AT by Cpctc. So that means that A is the midpoint. How do we know that? Because that's a definition of a midpoint. We're kind of going backwards from the definition that we did a minute ago, but it's still the definition. The definition says if you've got two things that are congruent, then the A in the middle must be the midpoint. All right, that one was kind of complex. We will probably do a little bit more practice with these in class, and we have this one that we need to get to in class as well. This one's a little bit easier. I bet you could even do this one your own, but we'll try it in class together.